Cars, trucks, and other vehicles can go both backward and forward. The driver must put the car in the correct gear for each direction. Hi, and welcome back. In today's science episode, I will talk about velocity and momentum.
Velocity and momentum. Velocity. You turn on the radio and hear a news story about a hurricane. The storm, traveling at a speed of 20 kilometers per hour, is located 500 kilometers east of your location. Should you worry? Unfortunately, you do not have enough information to answer the question. Knowing only the speed of the storm is not much help. Speed describes only how fast something is moving. To decide whether you need to move to a safer area, you also need to know the direction that the storm is moving. In other words, you need to know the velocity of the storm. Velocity includes the speed of an object and the direction of its motion. Velocity has the same units as speed, meters per second. If you had been told that the hurricane was traveling straight toward your house at 20 kilometers per hour, you would have known to evacuate. Velocity and speed. Because velocity depends on direction as well as speed, the velocity of an object can change even if the speed of the object remains constant. For example, race cars have constant speeds throughout the turn. Even though the speeds remain constant, their velocities changes because they change direction throughout the turn. Same speed, different velocities. It is possible for two objects to have the same speed but different velocities. For example, the two escalators pair moving at the same speed but in opposite directions. The speeds of the two sets of passengers are the same, but their velocities are different because they are moving in different directions. Cars traveling in opposite directions on a road with the same speed also have different velocities. Motion of Earth's crust. As you look around the surface of Earth from year to year, its basic structure seems the same. Mountains, plains, and oceans seem to remain unchanged. Yet, if you examine geologic evidence of what Earth's surface looked like over the past 250 million years, you will see that large changes have occurred. The picture shows how, according to the theory of plate tectonics, the position of land masses have changed during this time. Changes in the landscape occur constantly as continents drift slowly over Earth's surface. These moving plates cause geologic changes, such as the formation of mountain range, earthquakes, and volcanic eruptions. The movement of the plate changes the size of the oceans. The Pacific Ocean is getting smaller and the Atlantic Ocean is getting larger. The plate's movement also changes the shape of the continents as they collide and spread apart. Relative motion. Have you ever watched cars pass you on the highway? Cars traveling in the same direction often seem to creep by, while cars traveling in the opposite direction seems to seep in. This apparent difference in speed is because the reference point your vehicle is also moving. The choice of a moving reference point affects how you describe motion. For example, the motion of a hurricane can be described using a stationary reference point, such as a house. Figure 1 shows the locations and velocities of a hurricane and a car relative to a house at 2 p.m. and at 3 p.m. The distance between the hurricane and the house is decreasing at a rate of 20 kilometers per hour. The distance between the house and the car is increasing at a rate of 10 kilometers per hour. How would the description of the hurricane's motion be different if the reference point were a car traveling at 10 kilometers per hour west? Figure 2 shows the motion of the hurricane and the house relative to the car. A person in the car would say that the hurricane is approaching with a speed of 10 kilometers per hour, and that the house is moving away at a speed of 10 kilometers per hour. It is important to notice that Figure 1 and Figure 2 show the same changes, but they use different reference points. Velocity and position also depends on the point of reference chosen. Momentum. An object is moving at 2 meters per second toward a glass vase, like the one in the picture. Will the vase be damaged in the collision? If the object has a small mass, like a bug, a collision will not damage the base. But if the object has a large mass, like a car, a collision will damage the base. A useful way of describing both the velocity and mass of an object is to state its momentum. The momentum of an object is the product of its mass and velocity. Momentum is usually represented by the symbol P. And here you see the momentum equation. Momentum equals mass times velocity. And here are the units that you should use to represent each one. The unit for momentum is kilograms times meter per second. Like velocity, momentum has a size and a direction. Let's see an example problem. Solve for momentum. At the end of a race, a sprinter with a mass of 80 kilograms has a velocity of 10 meters per second east. What is the sprinter's momentum? What should we identify? The momentum. What do we know? The mass is 80 kilograms. We also know the velocity 10 meters per second east. So now you apply the formula and multiply. The result will be 800 kilograms per meters per second east. Our answer makes sense because it is greater than the momentum of a walking person, but smaller than the momentum of a car on the highway. Comparing momentums. The truck does because it has more mass. When two objects travel at the same velocity, the object with more mass has a greater momentum. So, in this case, which one has a greater momentum? The car or the truck? As I just mentioned, the truck. A difference in momentums is why a car traveling at 2 meters per second may damage a porcelain vase, but an insect flying at 2 meters per second will not.
I hope you found this video useful. Thanks for watching and until the next one. Bye!